Hello everybody. So in this video I want to show you how we can use the T-Formulae to prove trigonometric identities. So in a previous video I showed you that when t equals tan of theta over 2, we can apply each of these formulae in place of tan, sine and cos. So we're going to use these to prove sine squared plus cos squared theta equals 1. And we know we have sine theta, which is 2t over 1 plus t squared. So when we square this, we get 2t all squared over 1 plus t squared all squared. And this becomes 4t squared over 1 plus 2t squared plus t to the 4. So this is sine squared theta. We know cos squared theta is given here. And we can square this. We get 1 minus t squared all squared over 1 plus t squared all squared. So now we have cos squared theta and sine squared theta. We can substitute these back into our identity and we get sine squared theta plus cos squared theta will equal 1. So now we can add these two fractions together because they've got a common denominator. And then we can simplify the numerator, collect these 4t squares with this negative 2t squared. So we get 1 plus 2t squared plus t to the 4. And this is exactly the same as our denominator. So we have the numerator divided by itself is 1. So the left-hand side equals the right-hand side. So therefore the identity is proven. Okay? In example 2, we're going to look at another identity. So in example 2, we're going to use the same substitution to prove that sec theta minus cos theta is sine theta tan theta. And we've been given this condition because when theta does equal 2n plus 1 times pi over 2, this will result in dividing by 0, which we can't do. So we have to be careful with these conditions. Okay, so if we go back to our identity, we know sec theta is 1 over cos theta, and we know cos theta is 1 minus t squared over 1 plus t squared. So we can work out sec theta as the reciprocal of this. So we flip this upside down. So now we have sec theta. We can substitute the other T-formulae into our identity. So we've substituted sec theta in here. We know cos theta is given as a standard formula. So now we have to work out the difference between these two fractions. But to do this, we need a common denominator. So we'll multiply this fraction by 1 plus t squared, and we'll multiply this fraction by 1 minus t squared. And when we do this, we get a common denominator. We also get 1 plus t squared multiplied by itself. And for cos theta, we get 1 minus t squared multiplied by itself. So now we can expand out the brackets on the numerator, and we'll multiply out with this negative. So we get 1 plus 2t squared plus t to the 4, minus the 1, plus the 2t squared, minus t to the 4, all over 1 minus t squared multiplied by 1 plus t squared. We can tidy up the terms on our numerator. You can see that this one will cancel with this one, and this t to the 4 will cancel with this negative t to the 4. So we get 4t squared over 1 minus t squared times 1 plus t squared. So this is as far as we can go for our left-hand side. So now we can try and make the right-hand side the same as this. So if we have sine theta tan theta, we know sine theta is 2t over 1 plus t squared. That's given here. And we know tan theta is given here. We can multiply the two numerators together. So we get 4t squared over 1 plus t squared times 1 minus t squared. And this is exactly the same as what we have on the right hand side. So we can say the identity is proven. Okay, let's try one more identity. Okay, so for example 3, we're going to prove that cos theta over 1 minus sine theta is sec theta plus tan theta. Do you want to try and do this question yourself? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So the first thing we're going to do is we're going to write this as a division. We've got cos theta, which we can use this for, divided by 1 minus sine theta. And I've substituted this formula for sine theta into here. So now we can simplify this by writing this 1 as a common denominator with 1 plus t squared. So we've got 1 plus t squared, which is 1 over the same denominator. We can evaluate this by changing the divide to a times and finding the reciprocal of this fraction. And then you can see that this 1 plus t squared will cancel with this 1. So these two will cancel, and we're left with 1 minus t squared over 1 minus t all squared. So for our numerator now, we've got the difference of t squares. We've got 1 plus t and 1 minus t. For our denominator, we've got 1 minus t multiplied by itself. And these two will cancel, so we're left with 1 plus t over 1 minus t. Well, we know sec theta is 1 over cos theta plus tan theta. We can work out 1 over cos theta by flipping this upside down. We're given tan theta. We've got a common denominator, so we can add the numerator together. We get 1 plus 2t plus t squared, all over 1 minus t squared. We can factorize the numerator into 1 plus t all squared, and we can use the difference of t squares with our denominator. And then one of these 1 plus t's will cancel with this one. So we get 1 plus t over 1 minus t. And the left-hand side is equal to the right-hand side, so therefore the identity is proven. Okay? Well, I hope you found that useful, and that's given you a clearer idea on how to work with T-Formulae for trigonometric identities. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.